In this video, we're going to finish up our chapter 10 examples for business finance. Here we're looking for the average real return for treasury bills from 1926 to 1932. So what we're looking for is the nominal return adjusted for inflation in order to get the real return. So we're going to be using the Fisher formula to get the real return, and then we're going to take an average of that real return. So for the T-bill return, we bring those numbers from above, and for the inflation, we just bring those numbers from above, change them to numbers instead of percentage. So for our real return, we use our Fisher formula, which is 1 plus the nominal return divided by 1 plus the inflation minus 1. So 1 plus the nominal return divided by 1 plus inflation minus 1. And we should be able to copy that formula. Thank you, Excel. We add the sum of those formulas, and then we average. So the total sum divided by the number of years. So 1, 2, 3, 4, 5, 6, 7, 7 years. And the average real T-bill return of those periods was 7.48%, which is fairly similar to the average return for T-bills as we saw in a previous example for the 70s. So you can see that the risk-free rate, which is the same rate as a T-bill, has been fairly consistent for a long number of years. In example 17, we're going to look at what range of returns we would expect to see 68% of the time and 95% of the time. So we're going to have the lower return and the upper return. So if we have an average return plus our standard deviation, what kind of range are we going to see as a potential on long-term corporate bonds? So we have the low end of the return is the average return minus the standard deviation. So average minus the standard. So the lower return is negative 1.9%. So that's 68% of the time. For the lower return on 95% of the time, that is the average return. So right now we're building out how far out does the bell curve go. So for 68%, it's 1 standard deviation, and for 95%, we're 2 standard deviations. So we take the average, or that middle, minus the standard deviation times 2. And then for the upper return, the same, but we add. So what is 1 standard deviation away from the average return? That's where 68% of the information within our bell curve is. You remember statistics class and the chapter 10 textbook content and lecture content. And then 95% of the time, we are 2 standard deviations out. So we take the standard deviation times 2 to get the ranges for the 95% of the time. And those are all of the examples from chapter 10.